Hello everyone, welcome to the part 3 of my tutorial on nonlinear static analysis of geotechnical structure using Salome-Meca 2017. So in this part we'll see how the slope geometry is created and then how meshing is done, and then we'll use the Aster study module which is newly available in Salome-Meca 2017 to create the COM file, the command script which is needed by the solver Code-Aster, and then finally we'll analyze the slope. So here we go. Let us refresh our memory about the points what we have already discussed in part 1 and 2 of this tutorial series. So we have discussed what are the needs of an FEA, nonlinear finite element analysis, and what are their sources, and what is the general solution strategy of nonlinear problems. And in that we have discussed in detail the Newton and modified Newtonian methods. And now our job is to take up the example of using these methods. Now before we start, let us see the workflow in Salome-Meca 2017. The first thing we need to do is to create the geometry of the model structure which we want to analyze, and then we need to create the mesh on that geometry, and sometimes if necessary we may need to create a submesh which is a mesh within a mesh, and then we need to generate the command file. Earlier the command file was generated in a text editor, or there was an editor called FEA. Now in Salome-Meca 2017 they have replaced the FEA by a new module known as Aster study, which is much more user friendly than the earlier FEA. And what we do in this Aster study is, first we read the mesh, then we modify the mesh if needed. We'll see what are the situations when we may need the modification. Then we define some nonlinear material in this case and assign the material to the finite element model. Well, this is wrongly ordered. First, after reading the mesh, we need to create the model. Then we need to define the material and assign the material to the model. And then for nonlinear analysis, as we know that the load and deformations, everything are functions of pseudo time in case of static analysis, or functions of real time in case of dynamic analysis. So we need to create some functions expressing the load as function of time, and we need to create a list of time stations, time instants at which we want the analysis to be performed. And after that we need to define the loads and boundary conditions, and then we use the operator stat_nonline for nonlinear static analysis, and there we need to select appropriate solution method and select appropriate convergence monitoring strategy. And then of course once the analysis is over, we can visualize the results. But before visualizing, we need to output the results. We need to save the results in form of some file. There can be two types of file. One may be tabular file, a text file, or there can be a made file, which is a binary file that can be used for visualization directly. Of course, there are other formats available for outputting the results as well. Now, so this will be our workflow in analyzing a problem in Salome-Meca for nonlinear static loading. So let us go to Salome-Meca and then let us create the model and analyze. So let us start Salome-Meca first. We simply double click on the software. It takes a little time because it's quite a hefty software. Now this is the initial screen in Salome-Meca. I think all of you are familiar with. So in order to create the geometry, we need to select the geometry module first. Then it will ask me whether I want a new file to be created or I can open some pre-existing file. So let us select new in this case. So this is the geometry module where all these different tools are listed with different tools are available with their corresponding icons, or we can access those tools from this main menu also. So for our case, let us take up the slope. Let me show you the slope first. Let me show you the first slope. I'm sorry, I'm taking some time for this. Well, this is the geometry of the slope we want to create. So it's a 24 meter high slope and inclination is about 39 degree. So we have named the points, key points in the slope A, B, C, D, etc. And in order to create a submesh for a better resolution of the results, I have also drawn a red line here which covers the location where the possible failure surface may lie. So these lines will also be created in the geometry in order to create that submesh. And then we will create some points. We will monitor the results at some key points like toe or the top of the slope is an important. These are some two important points where the deformation can be monitored, should be monitored, so that we can identify if failure has taken place or not. And then we will create the results for the whole slope. So let us see how we actually do it. Let me stop this from here. Then let me go to the Salome-Meca once again. So first we need to create some points so that I can create the lines for the geometry. And this point creation can be accessed from this menu, new entity, then basic. Then we have all these different options. First option is point. We also have a shortcut here for creating the point, so you can use any one, whichever you like. So first let us create the first point. I have named it as A, and its location is at the origin, so 0 0 0. Then apply. Then if we plan properly the creation of points serially, then we can create the lines very easily. So we should plan accordingly. So let me create another point B at location 95 and 0. Then apply. Then next point, I'll name it as C. Location is 95 and 44. We can go to different submenus, items in a menu by clicking tab key, by pressing tab key. Apply. Then D. Next is D. So D, its location is 55 and 44. Apply. Then next is let me create the point Z at about 40 and 32. Let me see if it falls in correct value. Apply. Then I have the toe E, which is at location 25 and 20. Then apply. 25 and 20 apply. I think I have done some mistake. Let us see. See, these items are already there. So this vertex, and this vertex I do not need, but I have wrongly placed some key. So let me delete. So up to E we have created. Well, before creating D, between C and D, I needed a point I. So what I will do is I will delete all these things, and then I'll recreate them so that seriality is maintained. So ABC. Then I need a point named I at a location 65 and 44. Then apply. Then of course I need D at location 55 and 44. Then apply. Then I need point E at a location 25 and 20. Apply. Then I need another point called J at location 10 and 20. 10 and 20 apply. Then I need another point called F at 0 and 20. 0 and 20 apply. Close. Now let us see the geometry we have just created. You see, we are going to do a 2D analysis, so my points are lying on XY plane, so Z location is 0 for all the points. That's why I didn't fill anything in the Z location. Now we can see it from the Z axis direction. Then it looks like a slope. Now we'll need a few more points for defining the submesh within a zone. So let me create them as well before we proceed. Next we need another point called Z at a location of 10 10 10 10. Apply. Then I need H at a location about 65 and 10. I think I can apply and close, so all the points are already generated. Now we will create line. For creating line, what I do is first I select the first point of the line in this object browser, and then let us create line. So this is creating a line. So the first point is already selected, you see, A, and then if I select here B, then this line is already shown here with a pink color, line AB. If I apply, it will become red, so the line has been created. Then from B to C, so I can apply, then C to I. That's why the point creation should be carefully done. C to I to D, apply, D to E. So my slope line is generated now. Then D to E, then E to J, apply, then J to F, apply. Now I need to join this F and A, so point 2 I'll select as A from here, apply. So my main slope geometry is created. Then I also need 3 lines here from here to here, so let me create those lines. Now for that, first point I should select is J before going to line creation. First point is J. No, let me close this. Then now I'll select, so that first point is J, and then Z is the second point, apply. So I have got the line for the submesh. Z, then H, apply. Then from H to I was somewhere here, I, apply and close. So now we have created the 2 parts of the slope geometry by lines. Now what we can do is we can create, for ease of an creation of the faces, we can create some segments of lines, which is called wire in this terminology. Some segments of wire lines, which is called wire in this terminology. So let me create one wire using these 3 lines. Okay, so new entity, primitives, and basic. No, I think it is the menu is build wire. Yes, from build menu we can get wire. So wire 1. Let me select the objects, appropriate objects. Appropriate objects are this line, then I should press shift key, this shift line, and then shift this line. So apply and close. Then in order to apply the support conditions, I would like to have one more wire. So new entity, build wire. This is my wire 2. So this line, then by pressing shift, this line and this line. This is my wire 2. Now before creating the surface, let me select the lines or wires for creation of groups. Actually, creation of group is very much essential so that we can apply boundary conditions or loads on those groups, on those elements or nodes. So for us, my slope geometry, I'm assuming that this part is supported. This part has hinge or roller support, whatever you want, and then it will be loaded by self weight. So I want to create some group covering these 3 lines or wires. Okay, so let me select wire 2, then new entity, group, create group. Okay, and this group is of kind line. Okay, let me first create the point groups. I will need to monitor the deformation at this point and at this point. So let me create the points groups there. So the top point was D, so let me select D. Let me make it visible. Yes, this is D, and then let me create group. This time I will select the type as point because it is a point group, and then I'll name it top point. Main shape is D. Main shape is D. No, it's not coming. I'm sorry. Let me select this line. Let me select this line, and then let me create the group on this line. Group type. This is my top point. Then add, remove, let me see geometrical parts of the second thing. Second shape is point D. Add, let me see if it is created. Apply. Incorrect input data. Select one or more. Okay, and these are still not part of this thing, so let me not go for creation of group right now. I'll create the group after I create the faces. Alright, so now new entity, build face. I am building a face, and this is from face creation from wires or edges. So let me select the wires. I'll create one face for the outer part and another face for the inner part. So let me select for the outer first. So I'll call it outer. Then let me select the edges or wires. So this is one wire 2, then this line, then this wire, and then this line. So automatically this outer face is generated. Apply. Next, let me close it, then again open it, create group, build face. Now I'll create the inner part. So inner, I'll call inner face, and objects are this line, then this line, then this line, and then wire 1, no, wire 2, wire 2, then this line. I forgot to select wire 2, then I forgot to click shift key, so then this line and then this line. No, I should have selected, which one is wire 2? Let me make it invisible, and wire 1. I should have selected wire 1 and these 3 lines. So let me build the face once again. This is my inner face, inner, then wire 1, and then by clicking shift, this and this. So this next face is created. Apply and close. So when I make both the things visible, then now I get the whole slope. Now let us create the groups. Right now I will create the group of these 2 points, and for applying this support I will select wire 2. Okay, wire 2, yes, wire 2. Now new entity, group, create group. Group is of type point. Main shape is my inner, main shape, inner. Main shape. Let me select the wire and let me make this point D and E visible. Point D and FEA. Let us make it visible. Then let me select points and let me select this line as well. Sometimes you need to play a little. Let me see, 1 2 3 4. Let me make line 5. So yes, I think now I'll be able to create the group. Create group of point, line 5. The top is I'll call top point, and I'll select this point here, add, apply, and then I'll call it toe, and I'll select this one, then add. So apply and close. So 2 point groups have been selected. Now one thing we have seen that in order to select the point, I need to select the line first to which these 2 points belong, because the line 5 was created from this point to this point. That's why earlier I could not select them. Next, let us create the wires support. So let me select this face and then create group, so that I'll select wire 2. Let's select the outer one, new entity, group. This will be group of lines or edges. I'll call it support, and then I'll select this line, add, then this line, add, and this line, add, apply and close. So support is there in the outer face. Then in the inner face, okay, I think group creation is sufficient for this problem now. Now let us make this inner and outer visible. Let me save it before I proceed anymore. For 3, study 1. It is by default solved in HDF type. Now what I will do is I'll create, since I need to create a submesh, this whatever now I'll discuss is needed to do only when I need to create a submesh within a mesh. So in order to create the submesh within a mesh, what I'll do is I'll select these 2 partitions, these 2 outer and inner faces, and then I'll go for operation, then partition. Okay. So this called partition 1 will be the name of the partition created. It has 2 objects, and the resulting type will be face. And I should select this, keep the shapes of lower shape. I should select so that the lower shape things will be kept intact Okay, that means the individual shapes of these two faces will be kept intact. So let us apply and close. So partition has been created. Now that means both the faces has become a single entity now, but since I will need to create the submesh within the part of this whole thing, so I have to go for exploding this partition into the parts again. That is the only way out. So once again let us go to operations boolean, no, new entity build, sorry, explode, new entity explode menu. So partition subsets type is comp solid. Let us see what happens. Apply. Not a single entity has been found. Subset types I should use face, yes, because my original thing was face, so I should select as face and then apply and close. So this phase 1 and phase 2 has I have again got back. Okay, so this completes my creation of geometry for this problem. So what I have done is I have created a group here, I have created point groups here, node, which I'll be using as node groups later on. And now let us go to the meshing part of the job. For that, let me select the partition on which I want to create my mesh and then go to the mesh module. So mesh module. So we go to the mesh menu and then click create mesh. So my name of the mesh will be mesh 1, geometry is partition, it's a 2D mesh, already it understands. I need to select some algorithm, so I'll select NetGen 1D 2D, that is the easiest one. Then I need to select the hypothesis. I'll select NetGen 2D simple parameters so that I can select the select the size. Now I will create number of segments as 20. Let us see what happens if we do not, even if we keep the this thing default value, I can click OK and then later on I can edit the hypothesis, etc. Then add a set of hypotheses. 2D automatic triangulation I will select. Maximum length is 10.46. Let me go for the default value right now. Let us see what happens. Apply and close. Now I need to compute the mesh from here, or I can right click, or from here also I can get that same menu. So after selecting this, let me compute it. Nodes are only 72. It's a very coarse mesh. I think this is not going to give us a good result, so let me edit the mesh. So mesh menu, edit mesh. Now I'll be able to edit the hypothesis, etc. Algorithm is NetGen 1D 2D, hypothesis is 2D simple parameters. Now I'll make it maybe 25, then OK, then apply. No, something has gone wrong. Let us see. Compute, yes. Now it is a too fine mesh, so it is not good. It will be, the problem solution will be quite time consuming, so I don't need such a fine mesh. So let me again edit the mesh, edit, nudge into this simple parameters 2, let me go to 1 and then assign a set of hypothesis. Let me go for maximum size of say about 7.5. Let us see what happens. Apply and close. Compute. Now I think it is more or less a good mesh, more or less acceptable mesh for our purpose. Now I will have to create the submesh here. Okay, submesh here. So once again I will select the geometry and then I'll click create submesh. My mesh is mesh 1, geometry is partition, geometry is face, let me check first which one is phase 2 and which one is phase 1. Let me go back to geometry module and let me see which one is phase 2 is the outer one, phase 1 is the inner one. Yes, phase 2 is the outer one, phase 1 is the inner one. Okay, now I should have renamed it so that this confusion would not have occurred. So let me rename it by right clicking. So this is my inner part, I'll call it, and this I will rename to outer part, outer part. Okay, outer part. Then what I'll do is I'll again go to mesh menu. Now create submesh, create submesh. My mesh is mesh 1, geometry is now inner part. Okay, and then again I will select the algorithms in NetGen 1D 2D. Then I'll select NetGen 2D simple parameters. Number of segments will be more, number of segments will be say 8. Let me see what happens. Okay, assign a set, automatic triangulation. Well, here I get maximum size. Earlier my maximum size was 7.5, so I will need around 4.5 maybe for this case. Okay, apply and close. Now let us compute submesh. Yes, mesh 1 has some problem. Compute. Now I think it is more or less okay, but let me make little finer this submesh. They are almost similar, so edit submesh. Hypothesis, assign a set of hypothesis to the automatic triangle. I gave let me give 4.0, slightly small I want, or 3.5. let me give 3.5. okay, apply. Let me once again compute, sorry, let me compute and then let me recompute this. Now it is okay. Now it is okay. I think there is not so much bad mesh for this tutorial purpose at least. Now I can also see the quality of the mesh from this menu, mesh information. So here how many elements are there, everything is written here. Element info, quality info. Let me call it OK. No, I didn't get it. So mesh update overall mesh quality. Yes, I should go there, and here we see that aspect ratio of our elements, most of the elements have an aspect ratio of nearly 1, and very few have about 2.3. So this is a fairly good mesh, I think. And we can also get mesh information from here. So we have 589 elements, all of them are linear elements. There are 281 nodes, and then element info is not there, additional info based on geometry, then quality info, again I have got this. So fine. So this is the mesh and submesh creation part. Let us stop for now. We'll do the analysis creation in the next part of my tutorial. Thank you.